Okay, from the 17.1a assignment, I'm going to work out a couple of the solve the triangle problems. You will find that these solve the triangle problems come up again in 17.1b. So if you're in 17.1b getting confused, it might be good to come back and look at these. The first one I've selected is one where two of the sides are given. We have to find out the missing side, the missing angles. I already wrote down the ones we know for sure. Right angle, always equal to the C, 90 degrees. Opposite from my right angle is the lowercase c. I don't know lowercase c yet. There's B angle. Opposite from B is 15.2. That makes our lowercase b. A angle. Opposite from A is 13. That makes our lowercase 13. Or lowercase a for 13. Okay, I paused. Got rid of those extra lines that we don't need. Since you know two sides, probably the easiest thing is to use our Pythagorean theorem to find the third side. So I'm going to say a squared plus b squared equals c squared. My a was 13. My b was 15.2. And I don't know the c. So I know 13 squared is 169. I used my calculator to figure out that 15.2 squared is 231.04. And that is equal to c squared. Add those up, I have 400.04 equals c squared. We need to square root both sides. And I know we talked about this in the previous video, but when it's the side, you don't need to deal with plus minus on it. The square root of 400 would be 20. It happens that the square root of 400.004 is 200.0009. If I'm rounding to the nearest tenth, there's no way that that's pushing up any higher than it already is. Oh my goodness. Square root of 400 isn't 200. Square root of 400 is 20. 20.009. So if I'm rounding to the nearest tenth, I would say that that is approximately 20. I'm going to keep 20.0 so that if somebody looks at it later, they know that I did keep it accurate to the nearest tenth, even though it's looking like a whole number. Okay. Again, you can make this whole answer space down the side of here and fill in everything as you go. When I give it to you on a test, I will make that answer space for you, and I will fill in the ones that are already known so that you don't have to worry about those. If you're not writing in the whole answer space, then you need to make sure that you are circling answers. So many problems here have more than one answer. If you're not circling them all, how do you know that I'm going to even see them when I'm grading them online? Okay, let's look at what else do we need to find. The measurement of some angles. I don't know any angles, any sides. I know all three sides. I don't know any of the angles. So it doesn't matter which angle I start with. I'm going to look at angle A. If I'm looking at angle A, then this 13 that I know is opposite to the A, and this 15.2 that I know is not a hypotenuse, but it is touching it. This means this is my adjacent side. The only trig ratio we know that has opposite and adjacent in it is tangent. The only one we can deal with without having the hypotenuse. I know that tangent is the opposite over the adjacent. So tangent of the angle I want to know, capital tangent actually means something else. You won't learn that till pre-calc. Tangent of A equals the side opposite from A, which is always my lowercase a, over the side adjacent to A. And since C is the hypotenuse, this better be the B. I wouldn't usually bother to write that part down. I'd write tangent A equals opposite from A, which is 13, over adjacent to A is 15.2. Now, the only way to get the A out of its tangent is to use an inverse. And there are some teachers who make you write inverse tan on both sides and then drop it off. But I just go A equals the inverse tan of 13 over 15.2. Notice I did not do 13 divided by 15.2 and round off, because I don't want to round off until I get to the final answer. I get capital A equals 40.539, and of course it can keep going beyond that. But we want the nearest tenth. 40.5 followed by 3. It's not 5 or larger. We're going to leave it at 40.5. We're going to come over here, get some of the stuff out of the way that I don't need, and we're going to write 40.5. Don't forget the degree symbol. The only thing left on that list that we need to find is the measurement of angle B. And there's a couple ways to do that. In general, I prefer that you not reuse rounded off answers. So if I was going to be strict about that, I would say I need to go back and look at angle B. And if I'm looking at angle B, here's angle B. 15.2 is opposite from angle B, and touching or adjacent is 13. So I could say the tangent B equals the side opposite from B, 15.2, divided by the side adjacent to B, which is 13, which would give me B equals the inverse tan of 15.2 over 13, which gives me B equals 49.46 something. Nearest tenth, 49.4, but this time the 4 is followed by 6. 5 or larger pushes it from 49.4 to 49.5. I come over here, all right, 49.5 degrees. But that's a lot of work when there's a much simpler way. So even though generally I say don't use rounded off answers to get your next answer, when I'm doing just the last angle in the triangle, I often say a whole triangle adds up to 180, so I'm going to take 180 minus the 90 I know, minus the 40.5 I know, and find out 49.5 degrees is the measure of my last angle. And that's a perfectly acceptable way to do it. You just have to be aware that if for some reason you made a mistake on finding angle A, your angle B is going to end up wrong also. Here we have another solve the triangle problem from the 17.1a assignment. This time they didn't draw the picture for us, but I drew a picture for us. And I'll always draw it the same way. Right angle at C, opposite from capital C, lowercase c. One of the acute non-right angles at B, opposite from B, lowercase b. One of the acute angles, the less than 90 angles at A, opposite from that, lowercase a. That's the way I always set it up. And now I erase the things I marked already. Let me fix those for you. Okay, we now have one missing angle, two missing sides. The angle is actually the easiest one to fix. I know that a triangle adds up to 180 degrees. So way over here somewhere, I'm going to say 180 degrees. Take away the 90 I know. Take away the 68 that I know. And we end up with 22 degrees for the measure of angle A. That's not a rounded off number. That's an exact number. If I wanted to use it for future parts I need to work out, I could technically do that. But just in case I subtracted wrong, I always have a general policy. Use the original given numbers if you possibly can. So even though I know that's true, even though I put that in my answer blank, I'm not going to put it on the triangle. I'm not going to think about that if I can manage to get by without using that. I only have one side, so I can't use Pythagorean theorem this time. But let me look at what I do know over here. I know that I have angle B is 68 degrees, and I know that lowercase b is opposite from that. I have a hypotenuse over here along this side, opposite the right angle is my hypotenuse. It's not going to help me very much right this second because it doesn't have a number on it, but we'll see. And I have capital A, which, never mind, I'm not going to work with A. So I have this side A, which is adjacent to the B. So I'm going to start thinking about what can I do with opposite side, because I know the opposite side, and hypotenuse to find C, adjacent to find C, to find A. So opposite and hypotenuse. Let's work this one first. The sine of the angle B, because that's the one I know, is the side opposite from B, which would always be a lowercase b, over the hypotenuse, which is C. So in this case, I'm talking about the sine of 68 equals the side opposite from 68, 37.1, over the hypotenuse I don't know. This looks a lot like the problems that we did on side 1 of the notes, which was my video number 2 maybe for the notes. I like to put a 1 underneath here and cross multiply so that I end up with C times sine 68 equals 37.1. I need the C by itself. I can't just divide out 68. This word sine 68 all goes together. Let's divide by sine 68. Divide by sine 68. That's gone. I now have C equals, and I'm going to put that on my calculator, which should be 40.01 something. I'm rounding to the nearest tenth, so I'm going to call this C equals 40.0. Over here, 40.0. That's the end of C. I'm going to now try and work on finding the other missing side, which is side A, and I'm trying not to use the numbers I already found. Even though they look like nice whole numbers, they look like easy numbers to work with, I'm going to do it without that. So if I go back to my triangle, I see that opposite is the one I know for sure. The other one up here that has opposite involved in it is tangent. And it also involves the adjacent that I want. So I'm going to say tangent B equals the opposite over the adjacent. In this case, my opposite is 37.1, or B, and my adjacent is the A I'm trying to find. So we have tangent, let's get this some separation, tangent of the only angle I know, equals the side opposite from that, which is 37.1, divided by the side adjacent to that, which is A. Looks a lot like my setup beside this, except I've got tangent and I've got A instead of C. So I'm going to put a 1 underneath this. I'm going to cross multiply so that I get A times tangent 68 equals 37.1. I want to get my A by itself, so I'm dividing by tangent 68 on both sides. See if I can make this small enough to fit here. Tangent 68. This makes the tangent 68's cancel out, and I still have A equals. Put it in my calculator, I get 14.98. And this one's an interesting rounding situation because I want to round to the nearest tenth. And if you look at a 9 and it's followed by an 8, that means the 9 has to push up. If a 9 pushes up, the 9 kind of turns into a 10, but carrying the 1 up here. So I end up with closer to 14.9 or closer to 15.0? 15.0. Come over here, write it up here. Okay. That's all the parts that we needed to find in this problem. I will do some more solve the triangle problems as part of the 17.1b assignment. I haven't made those videos yet. I need to deal with whether or not I need to make up the notes video. Haven't looked at Mrs. Franken's notes. Sometimes I'll post hers, sometimes I'll make my own. If I post hers, even better for you because it means I have more time to work out some problems. So if you're having troubles, go ahead. But remember, you can email me. You can call me. Tell me you're having troubles with a specific problem. If I can't get it to you quickly in a few words in an email, I will make another video or I will write it out in details. Just because we're not in class doesn't mean that we can't get through this. Okay, let me know if you have more troubles. Here we go.